All right. Well, good morning, good afternoon, good evening, everyone. My name is Jason Walls from QA Cafe and Director of the Broadband User Services Work Area at the Broadband Forum. Thank you for joining us today. We're going to be covering some of the latest updates from the Broadband Forum and some exciting work that we've been doing in collaboration with members of the WiFi Alliance to bring you a real interoperable and standardized managed Wi-Fi solutions. And I have with me some special guests with us. I have Stephen Palm from Broadcom, who is very deeply involved in building the Wi-Fi Data Elements standards and the things that we've been working on together between WFA and Broadband Forum. So he's going to talk a lot about that. And I also have Tim Spetz, who, if anyone doesn't know, goes way back to the beginning of TR-69 and has also been working on putting these new capabilities into the TR-181 data model and expanding the progress of our new protocol that is the evolution of TR-69, which many people now know of as USP, the User Services Platform, or TR-369. We are using Zoom, obviously, for this webinar. So if you haven't used Zoom before, we want you to ask questions as you're going. Please type them into the Q&A box in your Zoom control panel. The Q&A panel helps us manage the questions a little bit better than the chat. So if you can, please put them in there. And then you can obviously adjust where we appear on the screen. Feel free to move our faces around if they're in the way. And you can also use Zoom's panel to zoom in and out if you find anything difficult to read or anything like that. Okay, so what are we talking about today? Open, interoperable, standardized Wi-Fi management is here. And I wanted to put this slide here because this is the key point of what we're talking about today, is that through industry collaboration, this very, very strong pain point that all operators have been feeling for a number of years now has a solution that has been built in collaboration with vendors and operators from across the industry, and is meant to be open and interoperable and fully standardized. And you can now implement that now that we've had this collaboration between WFA and Broadband Forum. And ultimately, that means, for operators, expanding your service offering, finally getting to those value-added services that everybody needs to get the usual benefits out of that. And how is that happening? So basically through some industry collaboration that's been going on for a while now, including the Wi-Fi Alliance's Data Elements standard that provides a number of KPIs and commands for managing Wi-Fi for use with its Easy Mesh network standard. And that all has been incorporated into the Broadband Forum's TR-181 device data model for USP. And in addition to all of the Wi-Fi stuff that is now available in there, there's everything else that TR-181 provides to develop these value-added services. You get all of that just by implementing this. We're going to talk about some of the specifics, and it's going to get a little detailed. So we do assume at least a little bit of familiarity with the data models and how that all works, but we're going to talk about the things that were added and the specific metrics that were added and how you can use them. And then this is all being communicated via this, the User Services Platform, which is now in version 1.2 and has been around for a couple of years now, is getting very quickly adopted by the industry. So I want to talk about that first, just so that everybody knows where all these standards sort of fit together. So the User Services Platform is made up of several standards. That includes the protocol itself, which is in TR-369, the data model that provides all of these capabilities, and that most people know of as TR-181, but it's the Device 2 data model. And then we like to say that there's this sort of trifecta between standardization and open source and testing. And so the Broadband Forum has OB USP Agent, which is the open source agent that people can use to start to implement USP. And then that's paired with the BBF.369 certification program to certify their solutions after they have implemented, everything they want to do and bring it to market. Now, this is, of course, now being complemented by the Wi-Fi Data Elements certification, incorporating the data elements standard into their certification program. And the WFA certification has been around for a long time and is very widely known. And so now the ability to verify that a device meets those, correctly reports those KPIs and does stuff like that is now part of their certification. So putting all of these things together will help you build with confidence, a interoperable managed Wi-Fi solution. But let's talk about USP a little more. We built it to enable these user services. We call it the user services platform for a reason. Managed Wi-Fi being the most acutely felt pain point, that brought us to where we are today, but a host of other things, analytics on the network scale, in general, building customer self-care applications. So, because we have this multi-controller architecture, you can put stuff anywhere and have it manage the pieces that you need to manage and build stuff for the customer to use and report their own information, stuff like that. We've been working heavily on building the concept of an app-enabled smart gateway that USP exclusively enables, and building a truly interoperable smart home too. Device, the TR-181 data model has a number of capabilities, and all the IoT stuff and proxy stuff that we've added to that helps that. Here are just a couple of the features that enable all that. And then I think that the most profound and most useful feature of USP is the fact that it's a multi-controller, multi-agent architecture. So it is the evolution of TR-69. And for those people who are familiar with TR-69, you have this sort of one-to-one relationship between the CPE and an auto configuration server. And, that's just how it was done first, mostly for firmware upgrades and configuration and stuff like that. But as we needed something more flexible, the best thing about USP is that it breaks that open and allows multiple controllers to interact with an agent and interact with the data model and configure the things that they have access to for the reasons that they need access to them. That's all done securely over end-to-end messaging. We built the protocol to be a little bit more flexible, especially when it comes to defining commands and events that are now defined in the data model. And that feature is part of what we've done in synchronizing with the WFA and collaborating around those commands to do Wi-Fi management and optimization. The other great thing is that it's not dependent on the cloud. So while we are building this to provide communication to cloud services and data and data collectors to do this optimization, it doesn't have to be. And that's we do have the use cases of the user having a USB controller on their phone and being able to interact directly with it, or having other controllers within the subscriber network doing everything that they need to do. We built it to coexist and evolve from TR-69, so there are even deployments out there where a device will have both TR-69 and USP on a single box doing the things that they need to do, with the idea that maybe one day they will migrate away from TR-69, but they don't really have to. We built out the proxy mechanism so that non-USP devices can be managed as well. And then we wanted to make sure that it would fit into a native cloud environment, because we know that's really important to a lot of people. So there is a northbound REST API that you can use to talk to a USB controller in a cloud native environment. I have a few chat things coming here. Oh, thanks, Rhonda, for putting those things up. So if you go into chat, Rhonda's posting a number of links that people can look at to learn more about these things. Ultimately, USP enables all of these use cases to coexist in a single ecosystem. I bring up this slide not to kind of go into the full details of everything here, but these are the features that enable what's going on here and what we're going to talk about today. Specifically, in the bottom right here, where we talk about the different capabilities that TR-181 provides. Those capabilities are the things that are exposed via USP. And it is a number of these things are the things that that have enabled the the use of data elements. And specifically, I'll talk about later near the end of the webinar the concept of our bulk data collection mechanism that really empowers how this all works. All right. So without further ado, I will turn things over to Stephen, who is going to talk about the WFA side of things with data elements and Easy Mesh.
Welcome all. I'm Steve Baum from Broadcom, and I'm going to talk a little bit from the Wi-Fi Alliance side. And so, Wi-Fi has been making 5G experience a reality for a long time. And when we see Wi-Fi 7 on the horizon, right, we're just going to make that experience even better. And really what's going to be driving those kinds of experiences is epic performance. You're going to see it in AR and VR kinds of applications, but just basically increasing the speed and, more importantly, lowering the latency. Those are really going to be the keywords for the next generation with Wi-Fi 7. And they're going to use some technologies like multi-link operations to do that, and really have some increased quality of service management aspects that are going to make Wi-Fi even better. So really is going to be leading to what also is called the 10G experience, where you can see up to 10 gigabits coming into the homes and being able to continue that throughput throughout the home with Wi-Fi. So in order to enable that, really clearly for the operators, that has to be well managed. And each generation of Wi-Fi, Wi-Fi 4, 5, and 6 has added new functionality and new features. And each time that happens, it actually makes it a little bit more complicated and complex. And so Wi-Fi Alliance realized this and really spent some effort to try and make it more manageable, have a dedicated program for figuring out these KPIs, getting them back to operators in a standardized method. And that's really where Data Elements was born out of. That even though there had been some data models in the past, they weren't really kind of heading towards the direction that Wi-Fi was going, with multiple access points in the home, multiple features that needed to be coordination between different sets of networks. And so it was specifically designed, Data Elements was specifically designed for to scale those fast operator networks, and really trying to maximize the deterministic costs, making sure that you could have glitch-free video and gaming and AR, VR, and then minimizing the latency, minimizing support call frequency, and support call duration. So there's a lot of techniques, even Wi-Fi 6 added, looking at the anticipated airtime utilization, again, very helpful for coordinating between the devices to help them help the schedulers on the access points provide better utilization of the airtime. So a lot of that, I'm not going to talk a whole lot about Easy Mesh, but Easy Mesh was all about having very well coordinated multiple access points in the home. Clearly, people started off with extenders and repeaters, and which weren't managed very well. But Easy Mesh really provided the foundation in an interoperable and standard and multiple vendor way of providing multiple access points in the home. And then Data Elements, again, was born out of trying to get that information, get that control to the operators for either analytics or customer care, all the reasons you need that extra information. I'll just kind of mention in passing too, Wi-Fi Alliance also worked on a project called Home Design, where we actually give very specific guidelines and actually a certification for new builders when they're actually building homes to put in Wi-Fi correctly. In that sense, right, everybody moves into a home, you expect the electricity to be working, you expect the water to be working, those kinds of things. Why shouldn't the Wi-Fi be working as well too? And so a couple of different builders got into that and certified many homes. But even if the builders aren't using it, it gives very good guidelines on how people should install Wi-Fi in their home and test it to make sure they're going to get throughput throughout the home. So again, kind of this combination of the easy mesh for the multiple APs, the data elements to bring the KPIs out, and just how to kind of set it up in the first place with home design have all been part of Wi-Fi Alliance's goal to have really good manageable Wi-Fi for operators. So just to slightly get a little bit detailed, the data elements are R2. So originally we started data elements in, well, about 2017, started first certification in 2019. And we started with a very basic core set of information. And that was really focused on getting statistics at every level and every function inside, in particular, the easy mesh networks. And so we really focused on is utilization that needs to be known at the radio level. And nowadays, the radios are hosting multiple BSSs, multiple Wi-Fi networks. And so for each of those, utilization was important. And each of those networks had stations or clients connected to that. And they were also going to have utilization statistics. And really pulling out and separating each of those kind of layers of information was the main driving of the early data elements work, and trying to keep it focused so that there wasn't a lot of extraneous. Well, with release 2 that we finished up late last year, a number of items had been added to Easy Mesh, a number of functionality. And so the means, the data model for those was added. And some of those included things that we had seen from Broadband Forum, like the device vendor information. That all came from the TR-181 data model, just wanted to know more about the devices. But then with the radar channel assessment, quality of service, prioritization, traffic separation, all of these that were added into Easy Mesh as increased functionality and features, we wanted to reflect those into the data model as well, and really keep pace, not having the data model delayed by years, or when these new features are being developed and tested and certified in Wi-Fi Alliance. Of course, Wi-Fi 6 and Wi-Fi 6E came out, and so we added specific information for that. I already mentioned the anticipated channel usage and cost for that. So really keeping track. And then we also found that there was a few model sets of information that people wanted to have, but weren't natively in Easy Mesh. And so it kind of worked the other way, that we took some of those requirements and we added what are called TLFs, or 1905 messages, that go between the Easy Mesh controller and the Easy Mesh agent to provide that information into the data model. So it worked synergistically to bring the information, the development both ways between data elements and Easy Mesh, since we were doing the work inside of Wi-Fi Alliance. Of course, the data model itself has some events, and in release 2, R2, we're adding commands as well. Now, at the time when we started data elements, we used JSON, and the data elements specification doesn't require any special transport, but we did need a way to test it. And so at the time we selected JSON for doing that. And the actual data elements models were written in Yang, but we provided this way for actually doing the testing, even though operators can choose to deploy whichever form that they find best, and of course, whichever transport. As I mentioned, in Data Elements Release 2, we started adding some commands for, as we called it at the time, remote configuration. And again, we wanted to make sure that at each layer, what's going on for the network, i.e. the entire home, at the device level, at the radio level, at the BSS or Wi-Fi network level, and the station level, commands for each of those. So I'm not going to go through each of those details, but are doing the normal kinds of things that you would want to do for controlling the network, how it functions, setting up QoS, if you want to separate the traffic, set the power. Those are the normal kinds of commands. And when we started to look at to do that, of course, the question of how to test these commands came up as well. And we looked for a while at maybe using some HTTP methods, but then really kind of our thoughts turned towards, there's probably a better way. Industry is really embracing USP. Perhaps this would be a good way to test. And so when we developed our test architecture, we already had kind of a test system that we're trying to simplify in that you could run what's called a quick track, which is basically you can take just a single laptop with a Wi-Fi device to do all the testing. And of course, we always wanted to allow single APs or easy mesh devices. And we had been, again, as I mentioned earlier, collecting the JSON information, the data model into our test tool. But when we were looking at how to control it during testing, our thoughts actually really turned to USP. And so we added the functionality in our test program so that the devices could use a USP agent, because we were going to add a USP controller and, of course, an MQTT broker to send the commands down to the test devices. And so really that allowed us not to have to invent something new in Wi-Fi Alliance, and then hopefully kind of prepare the test bed devices and the devices that were coming in to have a very practical way when they actually get deployed. So again, it's not required. People can choose to use other methods if they want to stick with TR-69 or however. But that really is, USP really is the method that we have for doing the testing. So just to quickly go through it, home design has been a while. Easy Mesh came out in 2018. In 2019, when we launched Data Elements, we originally published that as a specification in Wi-Fi Alliance and provided the data models in both Yang and JSON format. And then there was work done that was kind of initiated by Broadband Alliance to take that data model and bring it into TR-181 issue 2.13, 2 versions ago. And that was a little bit complicated. There was a few naming convention, the usual kinds of stuff when you move something from one group to another. And but that was a great start. Of course, more versions of Easy Mesh came out. And as I mentioned, the Data Elements Release 2 was launched in fall of last year. And again, we started with the JSON descriptions and the Yang descriptions. But then as we got to working on how we were going to test the commands and controls, again, that's where the USP came up. And so that's where we set the testbed architecture. That discussion that we were having between Broadband Forum members and Wi-Fi Alliance members led to, hey, let's actually put all of this into issue 2.15. Let's describe the work using XML so that we don't have any of those translation issues we faced in issue 2.13. And to make a long story short, all of Data Elements, including the commands and all of those new aspects of the specification, ended up in the device 2 issue 15 data model. It's available now, and that was just a very smooth transition and allows kind of a great synergy between the Wi-Fi Alliance and Broadband Forum for having a complete system for testing and getting these KPIs out of Wi-Fi systems. So the actual certification for Data Elements R2 will be out a little bit later this year. We're finishing up some of the test cases and things like that. And I'll just mention in passing too, home design will be updated. There's some new performance levels. We're going to raise that even more. Generally, we try to do the home design to allow for 10, 15-year horizon. And so it's been about 5 years, and we'll update that a little bit. So just kind of in summary, there was a lot of great work that was done between Wi-Fi Alliance members and Broadband Forum members to get a single data model into the TR-181. So I will hand it over to Tim now. Thank you.
Well, while Tim's getting set up, thanks for the questions that are coming in so far. By all means, ask them now so that we'll have some in the queue when we get to the end. And Rhonda has been posting some links to some of the things that we've been talking about. And like we said before, if you do have a question, please type it in the Q&A panel.
Can you see my screen okay?
Yeah.
All right. Great. Thanks, Stephen. Thanks, Jason. Yeah, so what I want to cover a little bit is kind of the nuts and bolts of what Stephen just described. Data Elements has been integrated in TR-181, the most recent one. It was, let's put it this way, not a trivial task. It requires a lot of work between joint members to bring that type of work over. And the one thing that was really key in that was the Wi-Fi Alliance moving over to XML to be able to provide an XML data model to the Broadband Forum in order to bring that the new work in. Before, I think it was probably a Word document, or it was probably a different type of form. XML is what we use to integrate into the TR-181 data model. That's what it's built on. And if anybody's been involved in the Broadband Forum work, when we go through straw ballot, it's quite a detailed process. So having it kind of ready like that really helped that process. And the fact that, Stephen showed you probably just a glimpse of how many parameters, commands, objects that were added. It was really integral to have that in the ready form so we could review them in that process. There wasn't any process to modify them or anything like that. So that helped a whole lot. And having the cross expertise, like I said, we have members from the Broadband Forum and Wi-Fi Alliance working together to kind of bring that in. And the key thing is now there is a process in place. The next time we do this, it is going to be a lot more streamlined. So this slide here is just to talk about, as Stephen mentioned, back in 2.13, we brought in the Wi-Fi Data Elements, but it was kind of disjoint from everything else we were doing as far as the way our data modeling works. We had a Wi-Fi multi-AP, which was describing similar things that the data elements were, and it was kind of overlapping, wasn't really connected with it. So what we had to do was some lifting insofar as cleaning that mess up. So what we did was we deprecated the hierarchy. So back one slide here. So it was a completely separate hierarchy at the time from data elements and from the native itself. So what we did is we deprecated that hierarchy. We pulled from that what was overlapping with the new data elements, any obsolete or deprecated, and we deprecated those parameters. There were still remaining extensions that we left. What we did was we integrated them into the data elements. So basically, going back to this, we've removed this tree here, and we've moved those objects into the Wi-Fi data elements area, and they're easily separable from it. So if you want to look at just the data elements, you can. If you want to look at it with the extensions, you can. And we made sure everything in what we had was multi-AP, was retriever, easy mesh, TLVs. So we did a full scrub of everything we had. We wanted to make sure that we're now, everything going forwards in concert with what's happening with the Wi-Fi Alliance. So moving forward, we have, like we said, a standard way to deal or to move things between the two groups. This helps when you're moving a large amount of data and there's a lot of detailed review process. It's good to have experts on both sides, a way to communicate it back and forth. It's really helped a lot. With this conduit, there's a reverse flow as well. So when we have ideas or thoughts or new concepts in the Broadband Forum, what we want to do is we want to go back to the Wi-Fi Alliance and work it into data elements so we don't have any separation. So anything that we're trying to do gets worked through the proper channels, comes back through data elements, and that way we have a way to standardize it across both standard bodies. And that's what we did today with 2.15, and we've lined it with 2.1. And we always put the call out to please come join and contribute. There's work still going on. So thanks, and back to Jason.
Okay, thanks, Tim. Let me get this back up here real quick.
There you go. Accidentally gave you the slide.
1 second. Oh, actually, you got the slide up there.
Yeah.
Why bother interrupting them?
Go ahead.
Okay, so it's funny because we had a question just come in about doing bulk data over MQTT. So this is the slide for you. The bottom line here is the combination of all these things really make all of this possible right now. And in particular, I wanted to call out bulk data collection. And bulk data collection has been around since TR-69, and originally it was done over HTTP. And the way it works is that you set up the things you want to know about using USP configuration, like sending messages and setting it up in the data model. And all of those components are in the data model. And that includes things like the parameters you want to know about and how often you want them sent to the data collector and the address and protocol of the data collector. So once you set all that up, you can then basically consume a large amount of data in either JSON or CSV over these different protocols and send them to a data collector. And that's really what empowers this this managed Wi-Fi with data elements is this bulk data collection mechanism. And so because it was so useful in USP 1.2 and in combination with TR-181 2.15, where we had to update the objects too. USP 1.2 now has the theory of operations in it for doing bulk data collection over MQTT because we knew so many people are already doing it. So the way that bulk data collection works, like I said, you can configure it via a USB controller to a USB agent. You say how often you want things sent. You configure what you want to know about and where you want it to be sent. And then the agent will periodically send that information to the data collector. The other thing you can do is actually make it a USB notify message. So if you want to use USP for bulk data collection, you can, and we do that. That will generally go to the controller that set it up, but that's done over a USB notify message. And so the other thing I want to point out about the combination of these three things is, there are a lot of solutions out there to try to solve this problem of managed user services, right? And not just for Wi-Fi, but for all sorts of things like parental controls and other analytics and user management and security and all these things. And the TR-181 for a long time has been a comprehensive list of these services. So anytime you're implementing these things, you're not going to just get a managed Wi-Fi system. You're going to get everything else that 2.15 has to offer, all in one system that's interoperable and multi-vendor. And I say app-enabled ecosystem in here too, because one of the beautiful things about USP, because of its multicontroller architecture, is we actually have many of whom are very highly participating Broadband Forum members who just build third-party applications, whether they're Wi-Fi optimization applications or security applications, things that are meant to be installed in the subscriber's network or on the remote gateway, that have taken a huge interest in USP because it helps them build these applications and allows them to just throw them onto another gateway and interact with their services that way. And that lets operators dynamically add services to their portfolio, just by using USP. All right. So, yeah, that's all we have in terms of giving you all a data dump, and we have a bunch of questions coming in, but I wanted to put some of the resources up here. You can find everything about USP at usp.technology. Specifically, I did want to call out the GitHub link to the open source USP agent. You can find that there. And then also, here's the link to how to the Wi-Fi Data Elements standard as well. And Rhonda has been diligently chatting at you through this whole thing, but we do highly encourage people to get involved. As more and more people kind of contribute to the Broadband Forum and the Broadband User Services work area in particular on this stuff, the faster it goes and the more accurate it becomes, and the more needs we end up satisfying. So please, by all means, if you're a member already of the Broadband Forum, it's very easy to get involved. We use some pretty standard tools for submitting contributions and issues and that sort of thing. We use Slack, and we're all very communicative people. And I always say that's the most fun you'll ever have in standards, which I realize is kind of a low bar, but okay, let's get to these questions. So panelists, I will leave it to you to click on a few things. Just go ahead and hit answer live if you want to grab any of these. I know there was one that I wanted to do about TR-456 and sort of the wireline wireless convergence stuff. So that work has been ongoing. And in the context of TR-456, so for the people who don't know what TR-456 is, it's one of the standards that our wireline wireless convergence group has made that defines a little bit of the architecture of how you're supposed to interact with the subscriber network. We have been working with that group on putting a lot of requirements into the remote gateway requirements document, which is known as TR-124. So I would invite the people asking this, who are wondering about this, to look at TR-124 and all of the wireline wireless convergence stuff that we've put in there. Tim?
Okay, let's see here. How do I know which one I'm answering?
Whatever one you want.
Okay, all right. The first one I'm answering, the question, when merging or deprecating parameters, how does it decide what to deprecate and what to keep? That was actually fairly simple. So what we did, again, we had a previous data elements copy in there, and there were things in the multi-AP area that were being written in because we knew they were going to be available in Easy Mesh. And lo and behold, when Data Elements 2.1 came out, they were there. So I would say a majority of the deprecation was just removing overlap, right? So we ended up having all this overlap. We removed that. There were a few parameters in there that we had anticipated were going to be supported by Easy Mesh, but weren't. So we removed those parameters. And a majority of the work was just kind of the cleanup and the aligning with what was in the data elements. So that was pretty much answers that one.
So I'll grab the one from Tom Starr. Good to hear from you. So he asked, what is Wi-Fi multi-link operation? And pretty simply, today, right, a client connects with a single AP. But with multi-link operation, they'll be part of Wi-Fi 7. A client can effectively connect to one or more APs, and they can be either full-time connections or switch back and forth. But that just adds just a lot more complexity of how the devices are connecting. And how that can reduce latency is a client could have two connections to two different access points. Both those access points could be on the same physical device, or they could actually be in two different devices. And one of the access points may have its airtime being used more than the other. And so the second connection could be used as kind of a fallback, depending on how soon it could transmit. So with having kind of two paths, right, there could be your main hideaway and then your secret shortcut that you use occasionally. And that would allow you to have reduced latency for that particular packet to be transmitted. So an exciting feature of Wi-Fi 7, but also a very complex feature to manage. So this is another good reason why people should be getting their data elements and USB and all this now for Wi-Fi 4, 5, and 6, because it's going to get that much more complicated when Wi-Fi 7 rolls in. Thank you.
I'll grab one really quick. It was about, can USB control be over MQTT? The answer is yes, but I wanted to call it out specifically because what we've done in so MQTT support for USB messages was added in USB 1.1. And then in USB 1.2, we've clarified a couple things when it comes to that. But also we actually ended up deprecating the CoAP protocol in USB 1.2. So now the 3 transports that you can use for USP are WebSockets, right? Set up via HTTP, MQTT, and STOMP. Tim, you want to grab another one?
Yeah, I might need, Stephen, I might need your help a little bit on this one because I clicked it before I read the whole thing. So it says, why is there no mention of the operation to be able to set up backhaul BSS in a multi-AP network, how to provision a BSS SSID keys? I think it's a 2-part answer, right? So yeah, you can set up BSSID and SSID keys. You can identify the backhaul network, but they're not from a configuration point of view right now in Data Elements. It's going to tell you what it is. We have some additions in multi-AP to try to distinguish, if it's a wireline or wireless link, that type of thing. But as far as provision, I know this has been a hot topic of discussion. I don't mean to put you on spot, Stephen, but what do you see coming down the road as far as provisioning this type of thing?
Right. So there actually is a command that was added. It's set SSID. Right. But it is not just the SSID. It also includes the password credentials or the security as well. Right. So that's in there, and that tends to set it's at the network wide level. Some people have talked about maybe needing more fine grained control of that, and that's something we can definitely explore. But generally, the assumption, especially for homes, is that if you're having 2 or 3 APs, you pretty much want the same networks on them. So that's why we did it network wide. So again, if people have special requirements and we want to do some more things, those are things we could add. And then to continue with the backhaul part, yes, all of that information is included. And so, yes, you can set the different links in there. We really didn't get into all the details today, but as you go look at the data model, you'll see what can be said on that regard as well.
Right. Great. Thanks.
Mm-hmm.
Just typing an answer real quick.
Yeah. Okay.
No. If there's another one you want to grab, go right ahead.
Yeah, I had. So we had a question about where can we learn more about scenarios associated with cost management and prioritization. I'll actually put a link in for Rhonda to put in just a second. But cost management, again, another program for Wi-Fi Alliance, right? Quality of service has always been a big challenge, right? We had Wi-Fi Multimedia or WMM for, 15, 20 years now. And cost management was really about when you're deploying costs, right? Let's do some, very obvious things on when you're mapping from the IP DSCP field to Wi-Fi. That was one aspect. The other is a feature called MSCS. You might have seen a command on the list there. And that's really mirroring the costs. And that's where it's assumed that the clients, when they're trying to do their applications, maybe a gaming application, really know what they need. And so, and there's a wide diversity of those. And so the AP, if configured to do it, will actually mirror what the client is trying to do. So there's a white paper on that. But the basic benefit of that is the operator doesn't have to go in and try and configure for this game or for that game or all these different scenarios. It will allow the client to inform the AP of what it needs. There's SES where the operator can control it. So that's a lot of detail, but I'll put information on that in Wi-Fi Alliance. And the good news is that is all configurable, again, with Data Elements R2, and we have the commands in TR-181 issue 2.15.
Perfect. Let me grab 2 really quick because they're kind of along the same topic. One was, when you're choosing an MTP. So we call USB transports MTPs or message transfer protocols because we didn't want to overload the term transport from a networking perspective. So apologies for making a new acronym, but we call them MTPs. So the question was, what are the criteria for picking one? Honestly, the reason why there were multiple had more to do with different use cases than it did us trying to entertain everybody's solution. So the way it went down originally is that we had CoAP and Stomp and WebSockets, right? And so CoAP was designed for in sort of the local network communication that needed to be really snappy. So for smart home applications, and then Stomp was our original message broker choice for communicating to cloud services, in a method that could be always on, and it used the usual benefits of a pub sub system. And then WebSocket was to have point-to-point links that are always nailed up for those legacy scenarios to make it very similar to TR-69. Now, that's evolved. We deprecated CoAP, realizing that we could just use WebSocket for the same thing. And in 1.2, there's a little bit of a description of how to do that. And then we also added MQTT because, honestly, that was just the most widely deployed message transport for these kinds of scenarios. And it was basically based on industry demand. So I would say that the choice really comes down to what network you're deploying in, rather than performance specifically, and the things that people will want to use for the use cases that they want to use. So I wanted to dovetail that into a question about resources, because it was they were asking if there's any hardware limitations of implementing this. And ultimately, so the TR-181 data model is huge, right? But you only have to implement the parts, just like MTPs, which is why I'm treating this as kind of a segue. You only need to implement the things that your device does. And then the nice thing about USP is that there is the get supported data model message, and that allows you to query an agent and it reports back to you its data model. And it could be very large, depending on if it has a lot of capabilities, or it could be very small if it doesn't have many capabilities. And so it will scale with the hardware limit. In theory, it'll scale in the hardware with the hardware limitations of the thing that you are modeling. And so, an access point is going to have a smaller data model than a full-fledged router, that kind of a thing. All right, who would like to go next?
I'm ready with one. So there was a question on the ETA of Wi-Fi 7 in TR-181. So Wi-Fi 7 right now in Wi-Fi Alliance is in the marketing task group stage. And so kind of the requirements are being set. One of the, the IEEE standard has a lot of things, but Wi-Fi Alliance usually focuses on kind of the industry market specific functions and features. So we're in that process. Right, that will lead to the technical work for developing a test plan based on those requirements. So those are being developed. We'll be doing parallel activity in the data elements group, just like we did for Wi-Fi 6 and Wi-Fi 6E, to come up with specific either the KPIs for that or any commands for figuring that. Since we'll be developing that more or less in parallel, and we have to be slightly careful. There was one little misstep we did with Wi-Fi 6 on certain naming and organization of the parameters that ended up changing when they were finally done in Wi-Fi 6. So we have to be a little bit careful of that, but we've been publishing more drafts. So as that's coming online with Wi-Fi 7, then we'll be putting in the data elements. And of course, with this way we've of managing between the data elements between Broadband Forum and Wi-Fi Alliance, we should be able to bring that over very quickly. So I would say this is really all based on when the Wi-Fi 7 testing is being more widely available inside the industry. So give that another year or two as that's being developed, but it should be lockstep with the development of the certification program and the devices with that to be able to manage that as well.
All right. Here's one I think we passed by real quick, but I think that we should probably answer. And Tim, or both of you can help me with it. It was the question about the backhaul. Did we already cover that?
The MQTT?
No, so just the other stuff in TR-181, the other interfaces that you can still manage. And I think I think the nature of the question was the interaction between the other backhaul technologies and interfaces and how it interacts with the entire multi-AP situation.
Yeah, I think I typed the answer to that.
Okay.
Yeah.
Yeah, and I think just to add, right, from the beginning of Easy Mesh, right, we understood that there would be wired technologies for those backhauls, right? Of course, there's Ethernet. Easy Mesh is based on IEEE 1905, which it supports other, Mocha and HomePlug and things like that if people use that. So all of how it is connected, right, is contained in the controller, so that those topology informations can be extracted as well too. So there again, if there were kind of some specifics that people were looking for, by all means, we'd love to hear some of these requirements. There is just a huge multitude of knobs and configurations, in Easy Mesh or in 8 access points. And so we try to get the low-hanging fruit, shall we say, in these KPIs when describing them, because we just don't want to throw them down and hope that they work. We actually do want to test them. We do want to have the certification program for them. And so that's why we do tend to prioritize them. So please let us know.
Exactly. We're very nice to work with. I did want to, there was one question about, the minimum set of features. So I want to answer this question because it's a good way to talk about certification really quickly. The question is there a recommended minimum set of features that a USB agent is expected to support? Yes, and the best way to find out the details of that is to look at TR-469, which can be found at usp-test.broadband-forum.org. But you can get there from usp.technology. And in there is some information about the minimum set of profiles that an agent needs to support to even perform the testing, but really that means to even support USB in the first place. So there are 2 different data models, even though the underlying core of most of the interfaces are the same. So TR-69 has some things that USB doesn't need, and USB has some things that TR-69 doesn't need. There are a number of things that are required for USB as a protocol to function, like the local agent object, et cetera, that are pretty much required for an agent to support. Otherwise, there's certain things you just can't do. So that stuff is listed. But the other thing that 469 lists are a number of feature IDs. So if you're seeking certification, you can you can look at that table and decide what features your device supports that you want to seek certification for, and that will give you more detail about about the things that you support. Now, beyond that, we do have a lot of we have what we call profiles in TR-181, and that gives you kind of an understanding, a baseline understanding of the things that you need to support a given feature, and those are found at the end of the data model specification if you're looking at the HTML. Rhonda, if you can do me a huge favor and find, I don't know if we have a quick access to the Omdia survey results, but there's a question here about, have there been any surveys of service providers to determine the timeframes of when they plan to adopt USB? Yes, we did that survey last year, actually, and it was very promising. I think it was 75% plan to deploy in the next 12 months from when we did the survey, so it's already out there. And then, we also did ask that question, as you know, anybody who registered, we asked a bunch of questions during the registration, it was very promising. So, but Rhonda will put that in the chat to the Omdia survey results that we did last year.
I've seen 2 questions about USB controllers being Easy Mesh controllers. So I'll grab that real quickly. So really, an Easy Mesh controller has quite a bit of aspects it must manage, and each of the Easy Mesh agents also do a certain amount that they must manage as well. So at this time, a USB controller probably could not completely replace an Easy Mesh controller, mainly because some of the real-time aspects of some of the transactions that must occur when you're steering clients and certain aspects are going on. So I wouldn't kind of say that the USB controller could replace it. That being said, right, if you're just kind of shooting for a certain level, There will still need to be an easy mesh controller inside the home, which is actually doing the communications and the layer 2 communications with the easy mesh agents and providing that management facility. But many of the main aspects can be controlled through TR-181 remote configuration commands. So I wouldn't equate those anytime soon. But certainly to control all the major aspects, the USB controller could have that functionality inside of that. But I think you will see, easy mesh controllers will be continuing as is, and there hasn't really been a plan for the controller in the sky talking to agents. There's kind of a philosophical debate on how those things should be done, but that's not really the architecture that Easy Mesh and Data Elements has envisioned. Great control of the Easy Mesh controller, but not replacing it.
Right, and I think that's the key, right, Stephen, is that what's in there now for Data Elements, the new commands, you're controlling the controller, and then it's still disparate. You're not sending USP commands directly to the extenders. You're still controlling the controller that's sending those commands, right?
Yes.
Right.
Yes. Let's see here.
And I think that probably the other point to make there is that, in the event that you have a CPE that is, going to have Easy Mesh on it, using USP to manage the firmware is one of the ways that doing all the initial configuration, the setup of all those things, from your what would traditionally be an ACS is definitely something that is a possible scenario.
Maybe one quick one about MSCS support already. Yes, there are some popular OSs and devices that I've seen some implementations on, but I'll let them do their own announcements. So on their timeframes of rollouts. But yeah, there's been a lot of interest, right? And it allows them to kind of say exactly what they want for quality of service and make it much easier for operators not have to know all those details when configured to do so. Thanks.
All right. Okay. Well, with 2 minutes remaining, I just want to give our final wrap up. Like we said, thank you everybody for joining us today. This slides and video of this will be made available to anyone who said yes to receiving further communication from us. Otherwise, we won't bother you. But eventually, we'll be up on YouTube as well. Please look into these resources if you need them, and all of the things that Rhonda has been diligently posting into chat. Actually, Rhonda, is there anything you want to say about the Q1 meeting? I know. So basically, if you're a Broadband Forum member, our Q1 meeting is going to be virtual.
The week of March 7th, Jason.
The week of March 7th.
Yes, and if your company is a principal or associate member, regional operator, you are welcome to attend. If your company is an auditing member, contact me for a guest pass. And if your company is not a member, contact me for a guest pass to attend. And you can sit in on these sessions and interact with these lovely people and get to know more about our work and how we work. So I've been posting in the chat, but if you contact me at info@broadband-forum.org, I will set you up with a guest pass. That's
Perfect.
it.
And we've been having a lot of fun. We've been having a lot of fun on this.
Yeah. You guys don't bite, so it's great.
Well, we've gotten a lot of good attendance. I mean, we've gotten a lot of good guest attendance. So
yes,
it's been nice. Sometimes it can get boring, but we try to keep it entertaining. All right. Thank you, everybody. And, we will be pushing out more webinars like these in addition to the Broadband Forum base events that are also that you can also attend that are webinar based for the moment until we go back to being live. So stay tuned and hope to talk to you all again very soon. Thank you, guys.
Thanks, everyone.
Thank you all.